Very good morning, my dear friends. Myself, Dr. M.H. Channaya, Vice Principal at Saptagiri College of Engineering, Bangalore, and former Principal at Dr. Shivakumara Mahaswamy College of Engineering, Bangalore. Friends, I welcome you all to my session on this design of lap joint. And friends, in the previous sessions, I have taught you what a riveted joint is, what are lap joints, what are butt joints, how do the joints fail, what is the mode of failure, and all this I have taught you in the previous sessions. And in today's session, I am going to teach you how to make use of the data handbook to solve any problem on machine design. Friends, in today's session, as I told you before, we have got a problem on this design of lap joint, which is double riveted, and the arrangement of rivets is by chain riveting. So friends, in the question it runs like this: design a double riveted lap joint with chain riveting for riveting two mild steel plate MS plates 20 mm thickness, taking the tensile stress equal to 90 Newton per mm square, the shear stress to 60 Newton per mm square, and the compressive stress as 120 Newton per mm square. Friends, here, before I start the actual problem, I am going to tell you some clue how to utilize the data handbook. And in the previous sessions also had just given the hint that in all the machine design data handbooks used by the students across the globe, you have a table of results of this riveted joint. In the sketch, they will give you about the type of joint, whether it is a lap joint or a butt joint, different types of the joints, the shear strength, the tensile strength, the module, longitudinal pitch, transverse pitch, etc. Here, the moment you have a problem on a riveted joint, you should get into the data handbook and find out or search for the table where you have got full information about this double riveted lap joint. Friends, in today's session, we have to design a double riveted lap joint. So when I say design a double riveted lap joint, means you will have to find out for the given size or thickness of the plates to be riveted, what should be the diameter of the rivet, what should be the longitudinal pitch, and what should be the transverse pitch, what is the margin to be provided so as to prevent the tearing of the plate. Then you have to find out what is the efficiency of the joint and in what mode, the mode of failure. So all these are the parameters that you are going to design in any of these riveted joints. Friends, let us get into the problem. We are designing a double riveted lap joint. So I am going to write the top view of a double riveted lap joint. So here we have two plates. This is one plate and the other plate. This is the other plate here. There are two plates, one placed over the other, and we are going to have the riveting made using two rows of rivet. This is plate number 1, plate number 2 you can see. So I am going to have two rows of rivets. This is the first row we have got 1, 2, 3 or 4. We can take some number of rivets. It is a chain arrangement. So we are going to have in the second row the rivet adjacent to the first row. I call this as row 1 or R1, and this is the second row of rivets that I call it as R2. So here the joint is a double riveted lap joint, means there will be two rows of rivets R1 and R2, and these are separated by a distance called transverse pitch PT, which is also called as the row pitch, and here this will give you the longitudinal pitch P, that is the pitch or the distance between any two adjacent rivets along the row. This is also the longitudinal pitch. This is also the longitudinal pitch. Friends, here after drawing this sketch, we have to find out, first of all, check what is the thickness of the plates given. In the question he says it has got a thickness of 20 mm, that is thickness of the plate to be riveted is 20 mm, and in some data handbooks they make use of the notation T. It is all the same. The thickness of the plates to be joined or to be riveted is 20 mm, and here a small procedure is to be followed. That is, we have to just check whether the thickness of the plates to be riveted is equal to 8 mm or greater than 8 mm. So, whenever the thickness of the plates is equal to 8 mm or greater than 8 mm, there is a formula relating the thickness of the plates and the diameter of the rivet given by D is equal to 0.19 root h to 0.2 times root h, where D is the diameter of the rivet to be used and small h is the thickness of the plate. Remember friends, here both D comma h are in meter. So that is very important, they are in meter. So friends, in this question the thickness of plate is 20 mm, and hence we can use this formula D is equal to 0.19 root h to 2 root h. So I just substitute the values of the thickness and I get D in meter. So I am taking D is equal to 0.2 times root h, say. So D is equal to 0.2 times root h. So 0.2 times h is the thickness given to be 20 mm, that has to be converted to meter by dividing by 1000. So you are getting this value of D equal to 0.2828 meter. Means for this specification or to just make this joint, we need a diameter of 0.28, not 28 meter, or if we convert that to millimeter, it comes to 28.28 millimeter, because in all the data handbooks the values are given in millimeter. So I have got the value of D is equal to 28.28 mm. So friends, when you go to a market, if you ask for a diameter 28.28, it will not be available, because across the globe, throughout the universe, there are some standards that are used, and you will have a value, a standard value or a standard size of the rivet available in the market. And hence here, if you refer to the data handbook, there in the data handbook there is a table which will give you the diameter, the standard diameter of the rivet, and also the corresponding hole dia. So they will give you diameter of the rivet, diameter small d, and the corresponding hole dia dh. So here we have got 28.28, and if you refer to the standard table, you get the nearest higher value is 30 mm is the value of D, and the corresponding hole dia, the diameter of the hole to be drilled in the plate is 31.5 mm. This is the standard value. So in all the further calculations, we should take the diameter of the rivet as 30 mm and the diameter of the hole to be drilled in the plate as 31.5 millimeter. So we have got the value of the diameter of the rivet, that is the first step, as D is equal to 30 mm. After completing or calculating the size of the rivet, that is the standard size of the rivet, we next calculate what are the different values of the pitch. That is, we have got two values of pitches. One is the longitudinal pitch, which is the distance between any two adjacent rows measured along a row. So this is the transverse pitch, and between the rows we have a transverse pitch, which is also called as row pitch. That is formalized there. Now we will have to calculate in the second step what are the values of P, the longitudinal pitch, the transverse pitch, and the margin to be provided for these. I think in the previous session I told you what margin is. That is the distance between the center of a rivet to nearest edge of the plate. This distance is called margin. From here to here It is called as margin, so as to prevent the tearing of the plate. Friends, let me tell you how to find out the longitudinal pitch P. So to find out P. Friends, here to find out P, we have a procedure in machine design. That is, we are going to find out the shear strength of the rivets in one pitch, the total shear strength of that in one pitch length. That means whether you have got 2 rows, 3 rows, etc. within one pitch length, how many rivets are there, what is the area of each rivet, and what is the strength of that. That is shear strength we need to calculate. So here we are going to equate the shear strength of the rivets, that is called as F tau, to strength of the perforated plate, which is called as F theta dash. F tau is the shear strength of the rivets in one pitch length. Friends, here you can observe here, if you take one pitch length, there are 4 half rivets, half, half, 1, this is half, 1 and half, and this is half. So in one pitch length, friends, you have got 2 rivets which undergo single shear, that is I is equal to 2 in this case. So friends, how to calculate F tau? F tau is the shear strength. So you should have the total shear area of the rivets, that is pi d square by 4 is the area of each rivet, multiplied by I will give you the total area, that is resisting shear, and if tau is the shear stress value, we are going to get this as I pi d square by 4 is the area of that, multiplied by the shear strength is the shear load the joint or the rivets can withstand. F theta dash is the strength of the solid plate, hollow plate or the perforated plate, a plate where the holes are drilled. That is, in one pitch length, we have got this value as P minus D into H into sigma theta or sigma tensile. Friends, in the previous sessions, if you just go through the videos we have given, you can find out we have explained everything in detail, how you get this value, etc. Friends, here let us find out what is P. Friends, here in one pitch length, I is half plus half, half plus half. Totally there are 2 rivets which undergo single shear, that's given by pi into d square, diameter of the rivet is 30, 30 square by 4 is the total area, shear strength is given as 60, and if you equate that to P minus D, P is the longitudinal pitch unknown, 30 is the standard dia we have selected, H is 20 mm, sigma theta is the tensile strength. Friends, if you equate these two, that is the shear strength of the rivets to the strength of the perforated plate, you will get the value of P, and this works out to 77.12 mm. So I am going to write down here, this is going to be the pitch, the longitudinal pitch is 77.12 mm is the longitude, that this value is 77.12. Next we will have to find out the row pitch or the transverse pitch. Friends, for all the riveted joints which have got the arrangement of rivets in chain form, this PT is given to be equal to 2D. PT is equal to 2D, that is 2 into 30, that is 60 mm. So along with this, in the same step, we also calculate what is the margin to be provided. So friends, remember, for all the joints, lap joints or butt joints, whatever may be the arrangement of rivets, this margin is a universal value and is given to be equal to 1.5 times the diameter of the rivet. So this is 1.5 times the diameter of the rivet is 30, so this is going to be 45 mm. So we have got the calculations made by the longitudinal pitch, the transverse pitch, the margin. So we have got all the required parameters for designing the joint. Friends, after this calculation, we have the other parameters like what is the efficiency of the joint. So You know very well, there are three efficiencies, namely the plate efficiency eta P, the rivet resistance eta R, and the efficiency in crushing is eta C. So let me calculate these values one by one. So first is A. A is eta P, efficiency of the plate is universal again friends. This is P minus D by P. So this P, that is to be multiplied by 100 as usual. So this value if you substitute, P is 77.12 minus 30 diameter divided by this P is 77.12 and this works out to 61.0991. Friends, I told you this you have to go up to 4 decimal place of accuracy, and this I have multiplied by 100 and this works out to 61.0991%. Next, the second efficiency is the value of eta R, that is the efficiency of the rivet. These values are straightly available in the data handbook in the chapter on this riveted joints. This is given by I pi d square by 4 into tau divided by pH sigma theta, that is strength of the solid plate, pH sigma theta. Friends, you know the value of I is equal to 2 multiplied by pi by 4 into diameter of the rivet is 30, that is square. Then shear stress is 60 MPa divided by pitch 77.12, the thickness of the plate is 20 mm, and then you have tensile stress as 90. If you multiply it by 100, friends, you get this answer as 61.105, 61.105%. So we are able to find out the efficiency of the plate, efficiency of the rivets, and finally we are left with the third efficiency, eta C. Eta C is the efficiency in crushing and is given by I times dH sigma C divided by pH sigma theta. You can just ask me how is that. So D into H is the area under crushing, into I will give you total area under compression, multiplied by crushing strength will give you the crushing load or the compressive load divided by the strength of the solid plate. And if you make this substitution here friends, you will get a value eta C is equal to 103.73%. Generally friends, you should remember eta C will be higher than eta R and eta P. Friends, for the given plate thickness and the diameter of the rivet used, we are able to calculate three efficiencies. One is the eta efficiency, that is eta plate 61.0991, efficiency of the rivet eta R is 61.105 and eta C, this is or the efficiency in crushing is 103.73. Friends, you should know by this time that the least of these three values of efficiencies is the efficiency of the joint. Here if you observe, eta P is 61.0991, eta R is 61.105, and friends, it is very obvious the least of all these three efficiencies is eta P, which is 61.0991. Friends, you can say here or conclude that the least of the three efficiencies is eta P, that is the efficiency of the plate, and that is the efficiency of the joint, 61.0991%. Finally, they will ask you to find out, or you have to mention what is the mode of failure. Friends, remember again, I am just repeating, if eta P is the least of the three values, the mode of failure is by tearing of the plate. By chance, if eta R is the least of the three values, then the mode of failure is by shearing of the rivets. And if eta C is the least, then the mode of failure is by crushing of the plate or rivet. So in this particular problem, we have eta P as the least value, that is the efficiency of the joint, and the mode of failure is by tearing of the plate. Friends, I hope and I am very confident that all of you would have followed the procedure followed in designing a double riveted lap joint with chain riveting. And one thing I would like to mention here friends, Instead of this lap joint, if you have a same problem with zigzag riveting, you will not have any change at all, excepting the transverse pitch PT which you are going to get will have a value equal to 0.33p plus 0.67d. Apart from that, the number of rivets failing, diameter of the rivet, everything remain the same. Friends, if you are happy with the presentation I have made on this design of lap joint, friends, do subscribe without fail, share the information with all your friends, and remember, this subscription will not cost you anything. Have a wonderful day. This is Dr. M. H. Channaya signing off.